When upgrading a 200 amp service, addressing overloaded conduits and managing multiple Romex cables requires careful consideration of the National Electrical Code, or NEC, and practical installation techniques. Several solutions can be explored to ensure a safe and compliant electrical system. Regarding conduit routing, firstly, consider splitting the existing 2-inch conduit into two smaller conduits. Each smaller conduit should be sized appropriately to accommodate a specific number of cables, ensuring compliance with conduit fill requirements. Typically, a 2-inch conduit might only accommodate a limited number of 12-2 cables, perhaps around 4, depending on the specific conduit type and cable sizes. Secondly, installing an additional 2-inch conduit alongside the existing one is another viable option. This provides sufficient space to distribute the existing cables and any future additions, reducing congestion and ensuring compliance with fill capacity restrictions. Thirdly, upgrading to a larger conduit size, such as a 2.5-inch conduit, offers increased capacity. This single, larger conduit can accommodate more cables than the existing 2-inch conduit, simplifying the installation and reducing the number of conduit runs. When using junction boxes, you can remove the outer jacket of the Romex cables at a junction box positioned close to the new panel. Then run individual conductors through conduits from the junction box to the panel. This method is permissible under Section 334.15b of the NEC, which allows the use of individual conductors in conduit, especially in situations where grounding continuity is not a primary concern for the cable assembly itself. Another option is installing conduit underground from the new panel to the crawl space. This approach eliminates the need for exposed conduit runs along the exterior of the house, providing a cleaner and more protected installation. Underground conduits must be buried at the appropriate depth according to local and national codes, and suitable for direct burial or encased in concrete for added protection. When considering panel location, firstly, we evaluate the possibility of installing the panel inside the house. Exploring alternative locations such as a utility room, closet, or basement area might offer a more practical and code-compliant solution. Indoor installations provide better protection from the elements and easier access for maintenance and repairs. Secondly, creating a separate enclosure near the existing outdoor panel is another option. This enclosure can house the new panel, junction boxes, and conduit termination points, minimizing the amount of exposed cabling and providing enhanced protection against environmental factors. The enclosure must be weatherproof and suitable for outdoor use, complying with relevant NEMA standards for environmental protection. Regarding Schedule 40 polyvinyl chloride or PVC conduit, Section 334.15b does not explicitly prohibit its use from the panel to the crawl space. However, it's crucial to ensure that the PVC conduit is properly supported, secured, and protected from physical damage. Adhering to NEC guidelines for conduit support intervals and protection against physical damage is essential for safe and compliant installation. When calculating conduit fill, refer to the tables in Chapter 9 of the NEC. These tables provide detailed information on the maximum allowable fill percentages for different types of conduits and conductors. For example, Table 1 in Chapter 9 specifies the percentage of cross-sectional area that conductors can occupy in different types of conduit. Table 4 provides dimensions and cross-sectional areas of insulated conductors and fixture wires. Table 5 provides the maximum number of conductors in trace sizes of conduit or tubing. To determine the allowable number of conductors in a conduit, use the following steps. Firstly, determine the cross-sectional area of each conductor using Table 4. Secondly, calculate the total cross-sectional area of all conductors. Thirdly, determine the allowable fill percentage for the specific type of conduit being used, referring to Table 1. Fourthly, calculate the maximum allowable fill area by multiplying the conduit's internal area by the allowable fill percentage. Fifthly, ensure that the total cross-sectional area of the conductors does not exceed the maximum allowable fill area. Section 310.15 addresses the ampacity of conductors and the requirements for directing conductors in conduit. When multiple current-carrying conductors are installed in a single conduit, their ampacity must be directed to prevent overheating. The NEC provides tables and formulas for calculating the appropriate dirting factors based on the number of conductors and the ambient temperature. For example, if there are more than 3 current-carrying conductors in a conduit, Table 310.15b3 requires the ampacity of each conductor to be reduced. The amount of dirting depends on the number of conductors. For instance, if there are 4 to 6 current-carrying conductors, the ampacity must be reduced to 80% of its original value. For 7 to 9 conductors, it reduces to 70%, and so on. When using junction boxes, proper sizing is essential to ensure there is adequate space for conductors and splices. NEC Section 314.16 provides guidelines for calculating the required volume of junction boxes based on the number and size of conductors entering the box. For example, a 12-2 wire requires a certain volume allowance, and the box must be sized to accommodate all conductors and devices installed within it. Proper grounding and bonding are critical for electrical safety. Ensure that all metallic components, including conduits, panels, and enclosures, are properly grounded and bonded to provide a low impedance path for fault currents. This helps to minimize the risk of electrical shock and equipment damage. Refer to NEC Article 250 for detailed requirements on grounding and bonding. When working with Romex cables, it is essential to protect them from physical damage. In exposed locations, cables should be protected by conduit or other suitable means. When running cables through walls or floors, use cable staples or straps to secure them properly. Avoid bending cables sharply, as this can damage the insulation and create a potential safety hazard. For underground installations, use direct burial rated cables or install cables in conduit approved for underground use. Ensure that the conduit is buried at the proper depth to protect it from physical damage and frost heaving. Backfilling the trench with suitable material is also important to prevent damage to the conduit. When terminating conductors at the panel, follow the manufacturer's instructions and NEC guidelines. Use the proper torque specifications when tightening screws and terminals to ensure secure and reliable connection. Loose connections can cause overheating and create a fire hazard. When working with electrical systems, always prioritize safety. To energize circuits before working on them and use appropriate personal protective equipment or PPE such as insulated gloves and safety glasses. If you are not comfortable working with electricity, hire a qualified electrician to perform the work. Always obtain the necessary permits and inspections before starting any electrical work. Local building codes and regulations may vary, so it is important to ensure that your installation complies with all applicable requirements. Inspections help to ensure that the work is done safely and correctly. Maintaining accurate records of all electrical work is important for future reference. Keep copies of permits, inspection reports, and wiring diagrams. This information can be helpful for troubleshooting problems and making future modifications to the electrical system. Regular maintenance of the electrical system can help to prevent problems and ensure safe operation. Inspect wiring, connections, and components regularly for signs of wear or damage. Replace any damaged components promptly. Test ground fault circuit interrupters, or GFCIs, and arc fault circuit interrupters, or RFCIs, regularly to ensure they are functioning properly. When upgrading an electrical service, it is important to consider the future needs of the building. Install a panel with sufficient capacity to handle future electrical loads. Run additional conduits or install larger conduits to accommodate future wiring needs. This will help to avoid costly upgrades in the future. When selecting electrical equipment, choose high-quality products that are listed by a recognized testing laboratory, such as Underwriters Laboratories or all. Listed products have been tested and certified to meet safety standards. Avoid using counterfeit or substandard products, as these can be a safety hazard. Always follow the manufacturer's instructions when installing and using electrical equipment. Improper installation or use can void the warranty and create a safety hazard. If you have any questions or concerns about electrical safety, consult with a qualified electrician or electrical inspector. They can provide expert advice and guidance to ensure that your electrical system is safe and compliant. By carefully planning and executing a 200 amp service upgrade, you can ensure a safe and reliable electrical system for years to come. Remember to always prioritize safety and follow all applicable codes and regulations.